This is my first lecture on circuit analysis of maximum power transfer theorem when the circuit contains a dependent source. See, this is the problem which is taken from this book, Fundamental of Electric Circuit, writer Alexander and Sadiku, and this is the practice problem 4.12. Okay, let's read out the question. For this circuit, we have to find out the value of maximum power that will be delivered to this load resistor. We have to calculate the maximum power that will be received by this load resistor. We know that a load resistor will receive maximum power when the load resistor is exactly equal to the Thevenin resistor, and last one is that that value of maximum power will be equal to the value of Thevenin square Vth square divided by 4 RTh. Okay, 4 RTh. That means at first I have to find out the Thevenin voltage. After that I have to find out the Thevenin resistances. So to find out the Thevenin voltage, at first I have to remove the load resistor across this A and B terminal. Okay, let's see how do I do that. Okay, see, at first I have to remove the load resistor across these two terminal, and the voltage across these two terminal will be known as our Vth. The voltage difference across these two resistance, these two terminals are known as our Vth. Now I may apply mesh analysis or nodal analysis to find out this voltage, but see, if I apply nodal analysis, I will see that this is our this will be our node 1, and this will be our node 2, and this will be our ground or reference node. Between two non-reference node, node 1 and node 2, a totally dependent voltage source 2Vx is connected. Okay, that means if I apply nodal analysis, I cannot proceed with, because when we apply nodal analysis, we simply apply normally Kirchhoff's current law or current. To calculate current, we need a simple voltage difference and resistor in the branch, but here the circuit contains only a dependent voltage source, no resistances. I cannot apply nodal analysis, rather I will apply super node analysis to find out these node voltages V1 and V2. See, here V2 is the voltage difference across this terminal and this terminal, and this is the same voltage across these 2 ohm, which is equal to Vx, and this same voltage is equal to the Vth. So I can write V2 equal to Vth equal to Vx. Now if I apply supernode analysis, at first I have to take the difference of this node and this node. This node has a voltage of V1 and its positive terminal is connected at this point, so I will write V1 minus V2 equal to the value of this voltage source 2Vx. So I write V1 minus V2 equal to 2Vx. Here V2 equal to Vx, so I can write V1 equal to 3Vx. After that I will remove this dependent voltage source across this node and merge these two terminal with a short circuit. If I remove the dependent source across these two terminal and connect this 2 point with a short circuit, then these two node will form a supernode. Now apply Kirchhoff's current law to this supernode. This current is unknown, so it will be outgoing. This current is unknown, so this will be our outgoing current. Only this current is incoming. So summation of outgoing current, that means V1 divided by 6 plus V2 divided by 2 will be equal to our 10 ampere, and V1 equal to 3Vx, from which I can calculate Vx equal to 10 volt. Now see, Vx is the voltage difference across this terminal, and this same voltage will be appear across these two terminals. So I can write Vx equal to Vth. Here Vx equal to 10 volt, so Vth will be equal to 10 volt. Okay, now after calculating Vth in the circuit where Vth equal to 10 volt, I have to calculate our RTh or Thevenin resistance to calculate the maximum power. Usually we find RTh using this formula Vth divided by In, but when the circuit contains a dependent source, we cannot proceed in this way. Rather we apply a new method which is known as test source method, which implies that when I remove the load resistance across these two terminal, I can apply a voltage source or current source in these two terminal. If I apply voltage source, I have to calculate the current. If I apply current source, I have to calculate the voltage drop across these two terminal. To calculate our RTh. If let's say I apply a current source of 1 ampere, here I test and I get a voltage difference across these two terminal which is known as Vt test, then I will get RTH equal to V test divided by I test. Here I test equal to 1 ampere, that means I just have to find out the value of V test. Now see, I will apply a different method which is known as test source method. I will apply a current source of 1 ampere between this A and B terminal, and that current will be known as our I test. And after applying this current source, I have to calculate the voltage difference across these two terminal, and that voltage will be equal to our V test. Here see, the voltage across these two terminal will be same as the voltage across these two terminal, and so I can write V test is equal to our V2, and same voltage is equal to Vx. Now look at this node 1 and node 2. You will see that a dependent voltage source is connected between node 1 and node 2. That means if I want to apply nodal analysis, I cannot. I have to proceed with the concept of supernode. And here, so before applying the KCL in the supernode, I have to write this equation. The positive terminal of this voltage source is connected at node 1. So I will write V1 minus V2 equal to 2Vx. Here Vx equal to V2, so I can write V1 is equal to 3Vx. This will be our equation number 1. After that, I will remove this current source and merge the. After that, I will remove this current source. After that, I will replace this current source. After that, I will replace this voltage source with a short circuit to apply Kirchhoff's current law to the supernode. See, if I remove the voltage source and replace it with a short circuit, these two node will be merged, and this node will form our supernode. Now apply Kirchhoff's current law to this node. Okay. This current will be outgoing, this current will be also outgoing, only this test current will be incoming. So this current is equal to V1 divided by 6, this current is equal to V2 divided by 2, and this current is equal to 1 here. So I can write summation of incoming current, this current, summation of this current and this current will be equal to this 1 ampere. V1 divided by 6 plus V2 divided by 2 equal to 1 ampere. Now see, what is V1? V1 is the voltage drop across, V1 is equal to 3Vx, and V2 is also Vx. So I can write 3Vx divided by 6 plus Vx divided by 2 equal to 1, which implies that Vx equal to 1, and this Vx is equal to our test voltage of this circuit. Okay, this Vx is the test voltage of this circuit, so I can write Vx equal to 1 volt. Now what is our Thevenin resistance? Vtest divided by Itest. Vtest equal to 1 volt, Itest equal to 1 ampere, so I get RTH equal to 1 ohm. Now what will be our PL max, maximum power transfer to the load? Vth square divided by 4 RTH. Here Vth square equal to 10 square 10, so I will write 10 square divided by 4 into 1, which will finally give us a value of 25 watt. Okay, so this is the maximum power that will be delivered to the load for this circuit.